refresh and see if we're on. Awesome. Okay, so welcome everyone to the official QCHack 2021 winners announcement ceremony. I just wanted to say and come on and say before we get started, it's been an excellent time. It's been an excellent hackathon experience. Just all the participants, all of you guys doing such a good job with your projects, sticking with us through working out some of the kinks, but all in all, like doing a really good job working hard on your projects, helping each other out, coming to networking events, all that other stuff. So just thank you guys so much for that. And then we also wanted to thank our sponsors a lot. There's a lot of people on this call. You can see some of them on the screen right now. They've put so much work and effort into making this an excellent experience for us as organizers, for you guys as participants, and just helping the quantum computing community as a whole. So thank you guys so much for that. And with that, I'm not going to talk for too long because we have a lot to cover in a short amount of time. But we will start with Kana from QBraid with the official winners announcement for the QBraid challenge. Take it away.
Yeah, so we had like 22 or 23 submissions, and we had so much fun going through all your submissions. And honestly, I learned so much in the past 2 days going through the various papers that you guys implemented. Our winner is Qteam, which implemented modulus exponentiation along with the Shor's algorithm. We really like their implementation. And then honorable mention goes to Quantronauts, which implemented this game called NIM. We had so much fun playing with it. Kudos to you guys. And a couple of more honorable mentions to Frozen Yogurt, Spammer, and the Team 33. And Qteam, we've already informed them, and we'll work with them to send their gifts. Is there anything else, Sean?
Nothing else. I mean, thank you. Congratulations to those winners. Yeah, nothing else from my end. Thank you guys so much for participating in QBraid's challenge. And I think we can go on to the next one. I don't know if Maria or Brian or Bob want to go next, but yeah.
I can go next as soon as I figure out how to present. Okay. Hello again, everybody. I second Kanav's sentiment. It was a great week. I really enjoyed joining a Quantum Coalition Hackathon and meeting you all and hosting the workshop, and of course, supporting you through the actual hackathon and then judging the submissions. A very quick overview of Microsoft Challenge. Those of you who participated know that it had two parts. One, implementation tasks for implementing the oracles for given classical functions, and the second one, a free-form project that explored the use of Grover search algorithm for solving problems. We had 40 submissions, actually. Wow. 12 of them were ambitious and did some form of free-form project. The rest focused just on part one, which I hope was also a good learning experience. And in our challenge, we have 6 winners. They all get the same prize, so, you know, everybody's a winner. But I'll go in the best traditions of announcing leaderboards from the lower position on the position of equal places to the higher ones. So our winner number 6 is a team of a single person who solved subset sum problem, a problem in which you're given an array and an integer, and you would be looking for a subset of array elements that adds up to this integer. Nice, solid implementation, but no visuals to put on the screen here. Number 5 was a very creative adaptation of a task from part 1, actually, triangle-free graph coloring problem. And it was adapted to seeking a diplomatic balance for a game of civilization. Big points just for the board game reference. Number 4, again, single person team, solving 4 rooks problem, like 4 queens problems, but with the rooks. You're given a board with 3 rooks already on it and are looking for a place to place the 4th rook. Again, not an exciting visualization to put in here. Number 3, we're getting closer to the most interesting projects. Grover Mind, a quantum version of Mastermind game, which I really enjoyed the visualization of, and the blog post about it. You can check it out here. Number 2, another game. Games are just so tempting to implement and make for great visualizations, I have to say. So in this project, we were looking for a setup for a 2x2 version of the Battleship game. So we wanted to place 2 ships, a big one and a small one, on a 2x2 field so that they don't overlap and don't hang out from the board. Also a nice blog write-up, and check out the project itself. And the big winner of our 6 winners, our number 1 project, is another implementation of Mastermind. But what they did, I just think it's brilliant. This team styled their project as a kata. So it's not just the project, it's a very detailed breakdown into building blocks of the project with descriptions of each block is doing. And best of all, it's covered with unit tests. The software engineer in me is just delighted. I would really love this team to work with me to bring this project into the quantum katas as a great learning resource. These are the 6 winners we have. Again, I thank everybody who joined our challenge, and here are some resources for you to stay in touch with us and possibly get involved with us further. It would also help us a lot if those of you who participated in the Microsoft Challenge filled this little survey. It's literally 3 questions, and it will help us make our next event better. Thank you again for the hackathon organizers for inviting us here, and I'm looking to many happy returns.
Excellent. Those projects looked super, super cool. I know for me, I had kind of a firsthand look. I was able to help look at some of those submissions and help with some of the automated testing parts, but kudos to all the people who submitted to that Microsoft Challenge. I mean, it was one very cool, one kind of not too hard of a task, but a pretty challenging task, and it took a lot of work. So kudos to you guys, and congratulations to the winners. So next we can have either Balint or Brian go. I guess whoever wants to go next.
Balint, it's all yours.
All right. So let me, I was trying to log into Twitch, but I'm not going to be able to share stuff, but we'll share details on the Quantum Coalition Hack website. So I'm just going to read things up. All right. So how fitting a coincidence is that, I don't know if you knew, but we have this closing ceremony for the first QCHack on April 14th, which is the first World Quantum Day, which is dedicated to celebrating quantum physics and quantum technologies to bring these closer to the general public. So it's pretty cool. I would like to congratulate the organizers, to Yale undergraduate quantum computing and Stanford Quantum Computing Association for pulling off a global event at scale with so many companies and 2,000 plus participants. I was very impressed with how smooth everything went and how responsive the organizer team was and how hard everyone worked to make this event a success, including other sponsor companies as well. Then, of course, this event would have not been possible without you, the participants. So thank you for all the questions and engagement throughout the event. And now let's focus on the 60 plus people who formed teams and submitted 29 projects to the Google Challenge. We are very impressed to get this much attention, given that we weren't completely sure that we'll have a challenge until last minute. Every one of you worked hard for 24 hours, dug deep into compiling small to large unitary matrices into gates that would work on Google's Sycamore chip. Some of you used GitHub the first time. Some of you used Python the first time. A lot of you used Circ the first time. Probably all of you drank a lot of caffeine. And thank you for choosing our challenge, and I hope you picked up something along the way. Hacking is about creating short-lived, imperfect solutions to problems, and it is my favorite tool to exploration and learning. Preparing the challenge was a hackathon for ourselves as well. It is definitely not perfect, but in the end, it served its purpose, and we all learned from it and explored the compilation together. So the challenge we came up with was to write a single function that takes an n-qubit unitary matrix and turns it into a quantum circuit that you can run on the Google Sycamore device. So I promised on the Google channel a couple of words on the solution. There is no right answer, but how I would have approached it is, so I can talk about it a little bit. So compiling unitary matrices in general requires exponential amount of 2-qubit gates, and this is evident from the theoretical lower bound for 2-qubit gates. In the general case, it scales roughly 4 to the power of n with the number of qubits. However, if you recognize a special structure in your algorithm, your quantum unitary, you might be able to go below this theoretical lower bound by exploiting that structure. So additionally, by trading off using ancilla qubits, certain structures can help reducing number of gates even further. The Sycamore device allows only for certain qubits, and its topology limits connectivity. So how I would have handled this is pretty similar to how the top submissions handled it. So first of all, handle the special cases first, identify those which can go below the theoretical lower bound, then handle the random cases, and then compile to the Sycamore architecture. So we do have compilation methods in Circ, and they were encouraged to be used and discovered for diagonal gates as well as for Toffoli's and the incrementer gate, which you can use ancilla qubits to make even more efficient circuit compilers. And for the random cases, we do have a 3-qubit decomposition using the quantum Shannon decomposition that could be generalized. So that's where I would have started. I implemented that 3-qubit method, so that's how I would have started it. And then compiling to Sycamore, I would have just used the optimized for Sycamore method and its arguments. In the end, the total score, like 100%, was very hard to achieve, or almost impossible without some actual research. So getting close to that is a big achievement. So before I go into the top submissions, the execution of the submissions sometimes ran into issues, like some submissions ran out of memory or went over an hour. That was our limit. So I could not do too much with those. Some basic syntax errors and repo management, if I could fix them, I fixed them. I went in manually and then looked at every failing case. So I got the email from everyone for the participation certificate, and I will send those out today or tomorrow. And if there's no score on it, that means that I couldn't get it work within the constraints mentioned. This just means that I couldn't make it work, but that doesn't mean the solution is not interesting or has no value. In fact, if you run out of memory or is running very long, probably there's some sophisticated stuff happening there that was very worthwhile, the 24 hours of exploration, and you learn probably a lot from it. So with that, I will comment on the top 3 submissions based on scores, which are all excellent solutions in their own ways. So from third place, for third place, we have the Midnight Worker team, which is Jivek Ryu from Harvard, with 4,477.99 points out of the 8,516, which I know weird numbers, but it's like 53% roughly the total achievable numbers, and it ran for 51 seconds. She showed thorough exploration and knowledge of the Circ APIs and deep understanding of the problem. She did not do the random unitary compilation above 3 qubits, as by the way, she gave a presentation on the final presentations, which was pretty nice. I really enjoyed watching her train of thought. She did find and use all the circ optimizers, including the 3-qubit matrix 2 operations, including compiling incrementers, and the Toffoli gates with decomposed multi-qubit control gates method. So congratulations, Jiwei. It's a really great achievement in 24 hours. In second place, we have a team name which was consisting of a bunch of hieroglyphs and a soon, coming soon icon. I could not translate on Google Translate it, and I wanted to have it read it up. It said soon sign. But anyways, I know that the team members were Andreas Butler from Caltech and Jamie Simon from Berkeley. So they achieved 6,515.56 points in 24 minutes of execution time. So that is roughly 77% of the achievable goal, achievable maximum score. They showed really deep understanding of the area. They rolled their own compilation for both the special cases and for the random unitaries. So they, this is actually closest to the direction we would go if we implement this in circ. They introduced no external dependency, handled the special cases with ancilla qubits, and they implemented their own recursive cosine sine decomposition-based random unitary compilation, which was very impressive. So congratulations and kudos, and I would recommend everyone to check out their solution. And then first place, drum roll, is the QCHack team, who's a one-person team with Alan Mee from Yale, who also gave a presentation, which I really enjoyed, with the very clean explanation, with the nice diagram of what's happening. And so he achieved 7,553.1 points out of the 8,500, which is 88% of the maximum achievable score, and took 18 minutes to execute. Now, this is where Alan's solution is different a little bit from the others, in the sense that he used external dependencies, which is fair game. It's a hackathon, and he had to explore these other compilers and plug them in. He did an excellent job. The code is very clean and nice. And he used Qiskit compilers for the special cases and OpenQL compiler for the random gates. He also recognized that the score system could be bent a little bit, and there was a built-in trade-off between optimizing for sycamore versus optimizing for length. And so he recognized that there's no easy way to predict that upfront. So he parallelized the execution of trying out all these methods, and then whichever was scoring higher based on our scorer, which he replicated in his code, he chose that. So with this, he basically scored the first place. So congratulations. And it was really cool engineering skills to see in work. And that's something that is closer to what we do in real life, in real applications, that try to plug things together that do the job, and we don't have to rebuild, reinvent the wheel. Fantastic. So that's it, and congratulations to all the participants.
It's nice to see a UQC member getting this representation at the top there. But thank you everyone who submitted to the Google Challenge. This one kind of caught my eye at the end. I think I'm just gonna try to work on something similar to this, or try my hand at this one after the hackathon is over. So I'm super excited for this. I finally get a chance to do something. But next, we'll bring Brian up from IBM, who will talk about the winner of the technical and creative challenge from IBM.
Hey everyone, thanks Shaun. Really happy to be here and to see all of you. First, I'm going to echo what everyone else has already said. Congratulations to all the participants. You did an amazing job. It was really tough. Hackathons are not supposed to be easy, and you all did a really, really great job. So hats off to you. The hat back on because I'm having a bad hair day. Another thing I want to say is congratulations to the entire organizing team at QCHack. The Yale Stanford Coalition has been doing some really amazing work. And I think I speak on behalf of probably all the companies when I say that it was really inspirational to see so many of you come together with this same purpose and focus. Congratulations on all of that and putting together a great event. So with all of that said, I'm also going to share my screen and put up a little slides to go over your results. So first off, I want to say this turnout was amazing. Really, really astounding to see this many people show up. You all should be proud, but also if you didn't win, you know, you were against almost over 2,000 other people in this event. That's crazy. That's a huge number for a quantum specific hackathon. You should be really proud of whatever you got to submit. And we had people from all different backgrounds here, which is another thing that I know IBM Quantum loves to see. We know that the industry is not just made of physicists or computer scientists. It takes people from all backgrounds to really move the industry forward. And so whatever you are studying or wherever you've gotten a background in, that's amazing. We want to see you keep working in that direction. Like I mentioned, it was hard and it was hard on purpose, but you should be proud of what you did. And before I go into the winners, I do want to just shout out, there were some QCHack advocates that were not only helping at this event, but also that helped plan the event. Actually, one of the main organizers at QCHack is a QCHack advocate. And the QCHack advocates are kind of the elite group of QCHack users around the world. They get mentorship from IBM, they get special events, they get a nice, neat website. So if you're interested in becoming a QCHack advocate, just Google that and you'll find the website. Not to give props to Google too much, but and finally, if you are a student that wants to put together your own event, I'm actually not a person with a quantum background. I didn't get my PhD in quantum information. In fact, I got my master's degree in biology education. And I ended up working for IBM Quantum doing this exact type of thing, working with students like yourself who want to do awesome things around the world. So if you're one of those people that wants to figure out how to put on your own QCHack or something smaller like a workshop, reach out to kidzkit.events@us.ibm.com and I can start a conversation with you there. Our overview of our challenges, as you know, we had 2 challenges, one entry-level challenge that was our creative one, and one advanced technical challenge that was focused on QCHack Pulse. We had 70 projects completed and submitted. So our grand prize winners here are going to get a custom designed Timbuktu backpack, which you will get to choose all the colors on and design it yourself. Our second place winners are going to get a tech pack of some fun little things with IBM branding on it. And our honorable mentions will be getting QCHack and IBM Quantum swag. So no more prelude. Let me jump right into the winners. For the creative challenge, our first runner-up here is the 3D quantum game of life. We've seen people put the game of life into code before and run it on quantum computers, but this team used a 3D model for it, which was really unique. So honorable mention to them, we'll be reaching out. Also honorable mention to the team that put together the Quantum Walk with Phase Kickback. This is another really great way to show the power and the creativity of our creative challenge. We wish you did a little bit more in your implementation. Our judges thought that this would have been a first place prize had you gone a little bit further, but that's the nature of a hackathon. You know, you only have a certain amount of time to get everything done. But great job, honorable mention there. Our second place winner is Quantum Hangman, or Rescue Schrodinger's Cat. This group built an actual game, a quantum hangman game to rescue Schrodinger's cat. Again, using that creative challenge to its full extent. Amazing job to this team. And our grand prize winner for the creative challenge was Team Q Power with their quantum, sorry, I have a typo here, but steganography, which was an amazing challenge. They also built a web app around using this that anyone's allowed to just log into and check it out. And we hope that they open source that in the future and just continue to show it off, because we were really impressed with this project and what they were able to put together in just 24 hours. Moving on to our technical challenge. Honorable mention to the iris dataset classification using QCHack. Our judges thought this was a really great project and wanted to see a little bit more from it, but again, great starting point. So honorable mention goes to you, as well as to dynamic traffic management with QCHack. Both projects that we thought had a lot of potential, and we'd love to see you continue to develop these projects in the community. The Qiskit community, as many of you know, is vibrant on Slack. We'd love to have you join and continue building these things, maybe with help of some of those Qiskit advocates that I was mentioning earlier. Into our second place, our runner-up goes to the project Show Me the Money. We were really impressed with this project as well. A great implementation, as you can see here, using Grover's algorithm and Qiskit Pulse. And our grand prize winner, which was a unanimous grand prize winner for the technical challenge, goes to Team QVengers with improving quantum audio processing methods with QCHack. Very, very impressive. Very impressive to all of our presentations. And now I'm just gonna need to stop sharing my screen. Very impressive to everyone. Hats off to you again. Great job. We'd love to see you again in a future event or workshop, whatever it may be. But stay out there, stay awesome, and don't forget to have a great day.
Excellent. Well, thank you so much, Brian, for going over those winners, and congratulations to the winners of the IBM Challenge. This is another one that I kind of want to look into myself. It's a really cool thing. It is more freeform and open-ended, but that's another thing. If now that these challenges are out and you can see what these other people have done, if you're watching this, go and look at what these people have created. Like, you can learn a lot from what they've built, from what your peers have built. So that's some really cool stuff that I guess I would suggest to those watching. If you missed out or if you want an opportunity to learn, that's a great one. I think next up we will do, I think YQI did a recorded video about the winners of the non-technical challenge. So Katerina can go ahead and play that. And yeah.
Good evening. My name is Florian Karl. I'm the manager of the Yale Quantum Institute, and we're delighted to be part of the Quantum Coalition Hack this weekend. We sponsor the QCYQI non-technical challenge, where we ask our participants to try to get the leadership of their fictional company to invest in quantum by submitting a 4-minute video and a white paper. The challenge was a tough balancing act to convince us the technology was worthwhile without overpromising quantum computing. We received 17 submissions total, 8 solo, 4 duos, 1 trios, 3 quads, and 2 full teams from all over the world. And it was a pleasure to review all the pitches. We were impressed by the quality of submission and all the work you put in this challenge in such a period of time. I will let my colleague and fellow judge for this challenge, Victor Padilla-Taylor, the Director of Mentor, Advisor, and Partner Networks at SciCity, the Entrepreneurship Center at Yale, to announce the winning team.
Hello, everyone. Hello, QCHack participants. In this short video, I want to share that for the non-technical challenge, I was looking to listen to a pitch that would convince me or my team at the Sci Center for Innovative Thinking at Yale to invest in quantum. I am glad to say that Richard, a student of computer science from the University of Sydney, provided such pitch. What did I like about this pitch? Well, Richard was able to give me the what, when, where, and how and why for a potential investment in quantum. In very simple and inspiring terms, his short pitch invited me to not only invest in what the future is for quantum, but also illustrated multiple areas for a possible thematic-driven investment. Richard did not only speak about big themes such as transportation, healthcare, crypto, and climate change, but also provided insights about where and when in the value chain there could be opportunities. My only suggestion for Richard would be to consider that thematic investments are usually a strategy embraced by large investors. For smaller investors like universities, a reduced singular vision could be more appropriate. For example, it would be more interesting if there was an investment thesis that supports allocating funds to transform existing giant industries, or that focuses on accelerators hosting only B2B quantum startups. In other words, instead of investing at the macro level, I think the question is about investments at the micro level. Regardless, I truly enjoyed Richard's visuals and presentation. Congratulations.
Congratulations again to Richard. I will send you an email shortly for you to receive your prize. Thank you to all the participants for these amazing submissions. And I will encourage you to post all your videos and white papers on the Discord channels for others to see. To continue to be engaged for everything Quantum at Yale, please visit quantum.yale.edu, and we wish to see you next year. Have a good night.
Excellent. So congratulations to the winner of the YQI collab with QCHack, a non-technical challenge. And with that, we do have Q Control's challenge, which Q Control has contacted me and said the winner, they will contact the winner today and let that person or that team know that they've won and take care of the prizes and swag for that. And we'll also have more information on our website if we can get info from them about that. But yeah, with that, that is the official winner ceremony for QCHack 2021. I don't know if our sponsors here want to say anything else at the end, but.
I can go ahead. Yeah, I think overall great event. Thanks to you guys. Echoing what has already been said, it's amazing how it all came together in such a short span of time. Kudos to you guys. And overall, I think it's really important to build a vibrant community. And thanks to IBM and Google for doing their part. And yeah, overall, I would recommend everyone to just keep collaborating. There's a lot of open source stuff. Contribute to IBM, contribute to QBraid, contribute to Google. A lot of the projects are already available. And yeah.
Excellent. So with that concludes the official hacking period. Oh, one more thing. Look out for a membership sign up for the Quantum Coalition. So QCHack this is not the end of Quantum Coalition or anything that we're doing as an organization. If anything, this is just the beginning. So we're gonna have we're even thinking about having some open source projects, more mentorship opportunities, more networking opportunities, just to get the overall quantum computing community together and really to connect undergraduate students, graduate students, potentially high school students. We're looking into that, and then professionals and researchers and stuff like that. So we will have a membership sign-up form out. We will also have a feedback sign-up form for us, for participants and mentors and judges and anyone else involved. And I'm sure some companies will have their own specific, company-specific and challenge-specific feedback forms for that as well. So please fill those out. Please let us know how we did. And yeah, otherwise with that concludes QCHack 2021. And thank you guys for coming. Peace, y'all.